Alright, in this video I'm going to look at how to balance out polyatomic ions. And in this particular problem, you can see that the polyatomic that we're talking about here is nitrate. This will work, or this method will work, for any problem that contains polyatomics. Now my clue that I had a polyatomic was over here when I saw that a group of atoms were inside of parentheses with a subscript on the outside. Okay, so whenever I have a problem that contains a polyatomic and I need to balance it, I balance out the polyatomics first. On the left-hand side, I have one nitrate, and on the right-hand side, I have three nitrates. Okay, so I'm just counting the nitrates. I'm not counting the individual atoms of nitrogen or oxygen. Okay, I'm saying I have one NO3 on the left, and I have three NO3s on the right. Okay. Now, to balance them out, that means I need to have three NO3s on the left. I'm short right now. So I'm going to give this a coefficient of 3, which is going to change it from having one nitrate to 3 copies of nitrate. Now we're balanced out in terms of the polyatomic. From here on out, it works just like any other balancing. Okay, so we're going to go from left to right. We're going to look at each element individually. So let's switch to our next element. We're going to look at boron. On the left-hand side, we have 2 borons. On the right-hand side, we only have 1. Okay? Don't get confused by this subscript 3 over here. It belongs to the nitrate. Boron itself has a subscript of 1 that's kind of hiding there. Remember, we don't write subscripts of 1. So we only have 1 boron on the right. We had 2 on the left. So we're going to give this a coefficient of 2. Now there's a problem here. Okay? And that is that when we give that subscript, or that coefficient of 2 there, that changes the number of nitrates. We now have 2, right, a coefficient of 2 here, times our subscript of 3, meaning we now have 6 nitrates, and we have the 2 borons that we wanted. The problem is that we've changed our number of nitrates. Okay, before we had 3 nitrates, and it was nice and balanced, but now we need to have 6 on the left. So we need to double this to a coefficient of 6, which will give us our 6 nitrates on the left. Okay, so I had to do that change because in balancing out the borons, putting this coefficient of 2 over here on the right hand side, I changed the balanced amount of nitrates. Okay, now, so our borons are now balanced out, our nitrates are now balanced out. The next element we need to look at would be the bromines. Okay, we have 6 bromines on the left, and on the right we have a lonely little 1 bromine, right? So real easy, pop a coefficient of 6 in here, and we're good to go, right? That's going to change our 1 bromine to 6, and it's now balanced out. So we have 6 nitrates balanced out, we have 2 borons on each side, so that's balanced out, and we now have 6 bromines on each side, so that's balanced out. Last but not least, we need to double check our hydrogens, right? So on the left-hand side, be careful about this. Okay, once we get a lot of coefficients in here, it can get a little confusing. But we have 1 hydrogen in the problem, and don't forget the coefficient of 6 that we plugged in. So we really have 6 hydrogens on the left. Okay, on the right-hand side, again, we have a coefficient of 6 over here. We have 1 hydrogen in the compound, so that means we have 6 hydrogens over here, which actually turns out that these guys are balanced out. Now our equation is balanced out. So that's how I would balance an equation with a polyatomic. The biggest challenge is recognizing the polyatomic and balancing it like the polyatomic is 1 unit that you can balance and you don't have to think about the individual atoms. Alright? Make sure you check out the problem on balancing combustion problems because they can be a little bit tricky too.